Hey guys, and welcome back to another video on the channel. In today's video we're going to be proving a trigonometric identity. So what we're going to be doing is proving that this is exactly equivalent to this, okay? So when proving a trig identity, we don't really want to be changing the left hand side and the right hand side. We kind of want to keep one of them fixed and turn one of them into the other. So most of the time we pretty much leave this one in place and we try and turn this into that pretty much, okay? That way we have pretty much a point of reference frame. Because if we're changing both of them at the same time, then it's probably going to get actually a bit harder than what it would actually seem pretty much. So pretty much all we're going to do is just start manipulating pretty much this expression to try and get it looking exactly like this, okay? Now, we've got cos of 3 theta here. Now that's a bit of a weird number. So like cos of 2 theta, that's more common, etc. Or just cos of theta. But cos of 3 theta means we probably want to be using a trig identity to break that up because it's not really a common thing, okay? Now, an identity that comes into mind straight away is using this one. So if you have cos of A plus B, that's the same as cos of A multiplied by cos of B minus sine of A times by sine of B, okay? Now the reason why I want to use this particular identity is because I can rewrite cos of 3 theta like so. So cos of 3 theta is the same as cos of 2 theta plus theta, or vice versa pretty much. And the reason why I want to use it like this is because theta and 2 theta are more common expressions that you can use in trig identities, okay? So this is why I want to use this particular identity on this expression here, because that will give me a cos theta, a cos 2 theta, a sine theta, and a sine 2 theta. So that will be allow me to use other trig identities, okay? So if we use that straight away, we can just write it like that. So if we just move this to the side, if it selects all of it, we can just move that to the side. So we can pretty much go, alright, cos of 3 theta is the same as cos of theta plus 2 theta, and then we're just going to sub into this formula. So cos of theta plus 2 theta, and you can just write that if you really want to. So cos cubed theta minus 3 cos theta. I'm just going to refer to this from now on as just the right hand side, so I won't write it continuously. But now I'm going to substitute this into this green formula up here. So if we do that, we're going to have cos, so this is your A and this is your B respectively. So you're going to have cos of theta multiplied by cos of 2 theta minus sine of theta and then sine of 2 theta, okay? So we have pretty much this expression here. So if I just move that here, this is equaling exactly this expression here. So if I just copy that as well, I'll just go copy and place it there. That's equaling that. So all we've done is we've just changed this to this expression here using a trig identity. Now, like I said before, the reason we want to do this is because of these guys here. You can use other trig identities. So two other identities that want to come up with this pretty much sine of 2a is the same as 2 sine of a and cos of a, okay? Another identity that comes up is if you have cos, there's actually a couple for cos of 2a, but one I want to look at in particular is cos squared of a minus sine squared of a, okay? Now the reason why I want to use this particular sine one, so this one here, is because at the moment I want this back bit here to eventually have a cos theta in it. Now at the moment it doesn't, but if I use this blue identity here, I'm going to get a cos theta in there, which is something what I want pretty much, okay? Now, the reason why I want to use this identity here for this part here is because I'll get a cos squared, and then if I multiply that by another cos, that'll give me a cos cubed, which is something I want in particular here. So that's why I'm using these two identities for these next parts here, okay? So now I'm going to move these identities to the side. So now you understand why I'm using those identities. Now we're just going to substitute them in. So we'll start off with the pink one here. So we'll have cos theta times by, this will be, so because it's 2a, this will be cos squared theta. So cos squared theta minus sine squared theta. So that's why that's gone in there pretty much. And now I'm going to do the blue bit, so that's gone there, and this will be minus sine theta times by 2 sine theta cos theta, okay? And now I'm just going to move these out the way very quickly, move that up there, and just copy and paste this guy down here, and just chuck a big equal sign next to it, okay? Righto, so now we've got a bit of a mess at the moment, so all we're going to do is just expand and see pretty much what happens with this. Why won't it go to the side? If we see if we can squish all that. There we go. There we go. Right, so first of all, we'll expand this guy out here, so that will affecting those corresponding terms. So this will be cos cubed theta minus cos theta sine squared theta. And now let's distribute the negative sine theta to pretty much this expression here. So what we're going to have is minus 2, and this will be a sine squared theta, times by cos theta, okay? And this is going to be equal to 4 cos cubed theta minus 3 cos theta, okay? Now, we're actually a bit closer to what we want in particular. So we can see straight away we've got a cos cubed here, we've got a cos term here and a cos term here. We're actually getting a bit closer, and we've also got our negative sign in here at the moment, okay? Now, what we can actually do before, we can actually simplify this, because these two here are actually like terms. So cos theta times sine squared theta is the same as sine squared theta times cos squared theta. So we can actually simplify the left-hand side to be this. So cos cubed theta minus 3 cos theta sine squared theta equals 4 cos theta cos cubed theta minus 3 cos theta. Okay, so we can see straight away we've already got the minus 3 as well. Okay, and we've got a cos cubed and we've got a cos term here. Now we want to pretty much get rid of this sine squared theta. Okay, we want this entire side in terms of cos theta. Okay, so an identity you could use is Pythagorean's identity. So if you have sine squared of an angle plus cos squared of an angle, that's equal to 1. So that means sine squared of an angle is 1 minus cos squared of an angle, okay? So what if we just substitute this guy into here pretty much and see what happens, okay? So this is pretty much a step I would take pretty much to get everything in terms of cos. I think it will actually work out, but not 100% sure, but we'll see how it goes anyway. So we can replace that in there, so we'll have cos cubed theta minus 3 cos theta times by, this will be 1 minus cos squared theta equals 4 cos cubed theta minus 3 cos theta. Now all we're going to do is distribute pretty much this entire thing to each of these guys here. So what we'll get is cos cubed theta, then we'll get a minus 3 cos theta when it goes to a 1, then we'll get a plus 3 cos cubed theta equals 4 cos cubed theta minus 3 cos theta. And we can see here, if we actually add up the like terms, we can see this is a like term with this, and we get 4 cos cubed theta minus 3 cos theta gives me exactly this side here. So I'm not even going to write it, I'm just going to copy and paste it because it's done. So this is how you do a trig identity pretty much. So now we've got left hand side equals right hand side, okay? So in summary, choose one side you want to change, okay? Then start looking at your trig sheet. Now start thinking of angles that are common in trig identity. So for example, they give you 5 theta. You want to break that up into like a 2 theta, what would that be? Let's go 5 theta. You could go 2 theta plus 3 theta, and then you can change that 3 theta again into this irrespective thing here like we did. So you want to think of common angles, okay? So you can use common trig identities, okay? The cubes will start appearing slowly but surely because you're going to have a couple squares involved, okay? So for example, you got that squared involved when we made a substitution here to get this respective thing. That gave us a cos cube straight away. So they're not hard to pretty much find, okay? But the trick is with these things is to just not give up and just keep having a crack at them and have a formula sheet with all the trig identities so you can slowly start putting them together, okay? But yeah, that's about it for this video, and I'll see you in the next one.